function 2 has a lot more going on to it. Let me help narrate your way through this a little bit. Let's start out with the domain here. The domain is negative infinity to negative 5 and negative 5 to infinity. So yeah, there's a little bit of a gap here, right? Where's the gap? The gap's just at that point of x equal 5. So let's see here. What do we got? That negative 5 to 5. Okay, so a little bit of a gap at negative 5 and 5. Looking at this bottom one down here. Let's take a look at a couple other things here. First of all, I've got some limits. So down at the bottom, I've got a limit as x approaches infinity of negative 1. What does that tell me about the graph of the function? What's going on there if as you approach infinity or negative infinity, the graph is approaching negative 1? Antonio? Yeah, you've got a horizontal asymptote. So let's fire up those asymptotes. There's actually one more asymptote in this graph, and you can see it right here. As x approaches 5 from the left, the function approaches positive infinity. As it approaches 5 from the right, it approaches negative infinity. That's the behavior of a function near a vertical asymptote. So in this case, it's going in either direction, depending on which way you're approaching this, but that gives us some asymptotes. So let's put those in. There's our asymptotes. You've got a vertical asymptote at 5 and a horizontal asymptote at negative 1. So eventually this function is going to get close to both of these. Now there's another little interesting thing going on with this graph, and that is it's not defined at negative 5, but it's defined on either side of negative 5. Let's take a look at what's going on. At negative 5, as you approach negative 5 from the left, the limit is negative 1/2. If you approach negative 5 from the right, the limit is positive 1/2. This should be a negative 1/2. My bad. That should be a negative 1/2 there. So what's going on at that point? Well, at negative 5, the function is undefined, but the limits still exist, right? What that's saying is that you've got a hole in the graph. So let's take a look at that hole in the graph. That hole is going to be right there at negative 5 and negative 1/2. So, okay. Y coordinates. How do you find the y coordinate of a graph? Yeah, plug in x equals 0. I think we're just going to have to go with plug in x equals 0 this way, 0, 0. Where is the function concave up? What tells us it's concavity? Second derivative. So the second derivative has to be what? Positive or negative? Second derivative to be concave up has to be positive. So that's where we can look over here. Second derivative is positive to the left of 5. So this is going to be concave up as long as you're to the left of 5, and then concave down to the right of 5. And there you go, concave up, concave down. Where is the function increasing? Well, I think you can kind of see it from the graph here, right? Function is increasing. That's a great question. Let's see what the chart here says to us. Let's go back over to here. What's going to tell us where the function is increasing and decreasing? First derivative. So right here, positive to the left of 5 and positive to the right of 5. When you look back at the graph, that matches pretty nicely. To the right of 5, this is increasing. To the left of 5, the graph is increasing. The only problem spot is at x equals 5 itself, where the function has a vertical asymptote. You also have another little problem spot at negative 5, but there's just a hole there, not anything disastrous like what we have over here with a vertical asymptote. So function's increasing from negative infinity to infinity. Technically, I guess you should put negative infinity to negative 5, union negative 5 to infinity, with parentheses and all those things, because at 5 itself, the graph's not increasing or decreasing, it's just undefined there. So, nice. Comments or thoughts on that one? Alrighty, let's wrap that one up.